So welcome everybody coming to this afternoon's, in Taiwan it's afternoon, in Europe, in Switzerland it's morning, early morning, to this lecture on the International Science Education Forum. And today we are very, very fortunate and honored to have to be able to invite Professor Kathrin Altwegg to give a lecture on, I think you can see her title, which is 3P's, which is patients, what's that? Patients and those are the most important thing, I think, in science, in scientific research and education, and just so that they are also characteristics of the Swiss people. I mean, so if Kathrin talking about it, I mean the most appropriate thing. But firstly, I was to say a few words to introduce Kathrin, and she was graduated from you were a student at Bern all the time, right?
No, I was graduating from Basel.
Oh, Basel, and then came to Bern to work for Professor Johannes Geis, and also Professor Hans Bausiger, whom I had the honor to know both of them because of the Giotto Comet mission. Yeah. And hence knowing that the mass spectrometer technology in Bern is unbeatable in the world. So I hope that Kathrin will tell you a little bit about how she got into the trade, and then going up to be one of the leading the scientists in this field, because with the scientific data obtained from the Rosetta mission to Comet 67P. I think that the data are so rich that it will take a long time, to analyze, and there are lots of very important things to be uncovered. And Kathrin, she's very experienced and very good lecturer in public lectures, so she's going to tell us her experience from her perspective. Yes, please, Kathrin.
Good morning, everybody, or good afternoon, I have to say. Here it's morning and it's a rainy morning. I'm going to talk about the 3P's. 3P's you need to become a good scientist, but also the 3P's you need to transfer to the young ones, so that we have good young people going into science, into STEM subjects. I don't know what you know about Switzerland, but I'm pretty sure that you know this. We have nice mountains. We do have cows. We also have watches. And we have direct democracy. Sometimes where people still go to a place and vote and elect officials, vote for or against a few things. So this really works. We even vote about the horns of the cows, if they should have horns or not. And we vote if we want to have more vacation. That was a clear no. We voted the last time, we voted about 3 weeks ago, if we should enhance the salary or the pay for the elderly. That was a clear yes. So we vote at least 4 times a year. What you may not know about Switzerland is this here. Women were forbidden to vote till 1971. So we were very late in women's rights. It's still like this. Women earn less money. They are in jobs which give you less money, and they earn less money if they have the same jobs as men. It's about 9% now, the difference. It gets less, but it's still there. And women in STEM, the total diploma given, it's about 23% in STEM. of all university diplomas. But here, Switzerland is very low if you look at how many women you have in STEM. And that's really something we have to change. Most of the other countries here in the Netherlands, they have less diploma in STEM overall, but the percentage of women is higher than in Switzerland. So, yes, we can. And my talk will be a lot about women, but of course, it's also for boys, for men. Many men have the same problem as the women here. If we look at the percentage of women in parliaments, you see it's going up slowly, slowly, slowly. And by 2055, I expect that we will be 50-50. If we look at the percentage of female professors at the ETH, that's the most prestigious university in Switzerland. It's a technical university. You see we are pretty low at 13% at the moment. And if this trend continues, we will be 50-50 by 2092, which is still a very long time. And so since I retired mainly, but even before, my purpose is to get here this trend a little bit faster, if possible. And it's clear there is a leaky pipeline at the ETH. You see, we start with 32% women and 68% men as bachelors. This stays constant up to postdoc, more or less, and then we lose the women. And this, of course, has to do with women, first of all, having children, but not only, it's a male world here. But this starts much earlier. In high school, students can choose their focus subjects. It's in German here, sorry for that. But if you look at that here, orange is philosophy and psychology. These are men, few men, much more women. Then we have economy, much more men, much less women. For biology and chemistry, it's about equal. It's not that different. But then we have physics and mathematics, and you see men are much more abundant than women here. So that's already in high school that this leaky pipeline more or less started. And this here is in numbers. That's engineering, 12%. Women, information technology, 24%. Mathematics, 21%. Physics, 18%. So these are all low numbers for women here, and which is definitely not a good thing. But if we do events, look at these girls. They are fascinating by what they are doing. Here she is launching a plastic bottle rocket, and she is making a comet. They are absolutely fascinating. It's the same fascination for men and for women, for girls and for boys. So something goes wrong after that, or sometimes even before that. Sorry. If I look back at my career, I was born in 51. So I went to primary school in the late 50s. And you see, we girls, we learned to knit. And the boys here, they had mathematics. I always claim that that's clear. Boys had more difficulty to understand mathematics than girls. So we could knit while they were still struggling with algebra. And then later on in high school, we girls learned to cook. and the boys had sports. This is unbelievable now, hopefully. When I studied in Basel, I studied in solid state physics, so not astrophysics or astronomy. I was the only woman in my class. It very often looked like this. The men did the experiments. The women could look. We even had a professor who told all the women, not only me, that they should stop studying, but better go to a department store and sell stockings. And another professor told me that he knows that girls or women don't know how to solder. He would do it for me, so I never could learn. And finally, no, for the exam, the professor told me that he knows that women are not good in physics, so he would ask me easy questions, which he did. But he gave me not a good grade for that. Also, I knew every answer. So that was my career. And that's the past, of course. Is it really the past? Just look at Google. I have two granddaughters. They are still very small. One is just 1 year old, the other one 3 years old. If I Google toys for girls, that's how it looks. Pink. You see what girls are supposed to do. They have to play with houses, being a housewife. And if I Google the same for boys, then you get this picture. And you even see it from the colors, that there is a difference between boys and girls. And that's how it looks. And this in the year 2024, not in the year 1951, when I was born. So it's not too much which has changed since then. After graduating and doing a PhD in Basel on solid state physics, I moved to New York, did some physical chemistry, and then I came back to Switzerland. I ended up by chance, actually, in Bern with Professor Geis and Professor Balsiger. And I was fortunate because at that time, the Giotto mission to Comet Halley just was being built, the instrument in Bern, and I could do the software for this instrument. And that's how I stayed in Bern. And I always claim I didn't look for astrophysics, it looked for me. And that's probably what it has to be. So finally, in 1996, I became the project manager of Rosina, the instrument built in mostly in Bern, but not only. And that's when I really got my passion, but I also learned patience, and I learned to play in a team, because space research you cannot do all by yourself. And I found out that what you need are excellent mentors if you want to be successful. So Professor Geis, he was born in 26. He, in the 1980s, convinced, together with a few colleagues, he convinced ESA that the mission to be done should be a comet mission. And he was planning for that for about 10 years. From him, I learned everything about astrophysics, because before that, I was a solid state physicist. So he was my teacher in astrophysics. I learned that if you are studying comets, then you study every stage of the evolution of the material in the universe, starting from interstellar medium through molecular clouds, through star-forming regions, through the protoplanetary nebula, solar system, and finally life. And this really was fascinating to see that. I didn't know before, and I'm very glad that I had the opportunity to learn that. Of course, this all depends on physical and chemical conditions. Rosetta had a long way to go before it ended up to be what it was. So there was a plan A, a plan B, a plan C. It started out as a comet sample return mission between ESA and NASA. It became a comet rendezvous mission between ESA and NASA. It was an international comet mission with 2 landers, a French-American one and a German one. And finally, it became what it was in the end. It was a European mission with a comet rendezvous and an asteroid mission with 1 lander, French and German. So that was the first 10 years of this mission, Professor Geis. The next 10 years, that was Professor Balsiger's time. He was responsible for the design and construction of the instrument. And he asked me if I would become the project manager. And that was my big chance here. He brought together a team, a very international team. And he was a very good diplomat, a poker player even. He had all teams which could have been competitors. He asked them to be part of our team. So there was just 1 team for the mass spectrometer, containing all labs which were active in this field worldwide. But he also brought together the Swiss industry, because this instrument had to be a joint venture between university and industry. That's how we get the money to do such things. So he was really my mentor for diplomacy and also organization. How do you organize an instrument with so many players here and be successful in the end? So that's what I learned from him. And I also found out that behind each successful career, there are 2 important persons. One is your partner. Fortunately, I have a very supportive partner. I have been married now 40 years to the same guy, and he's also a physicist. I got to know him during my PhD thesis, and he always backed me. And the other person, of course, was a boss with a vision. That was Professor Balsiger. And of course, Geis, but mostly Professor Balsiger. I remember when we started out with the Rosina instrument, we had to work together with the industry, as I said. And then industry, together with the government people responsible for the funding and with ESA, they came to Professor Balsiger and told him, you know, such an instrument with such a big cost of 60 million Swiss francs about, this cannot be managed by a woman working only part-time. And then Professor Balsiger said, she can do it. And that was it. So he backed me all the way. He was always there when I had problems with industry, with our partners, with ESA, whatever. He backed me, but he let me free. He let me do my job. And that's the instrument we built, 2 mass spectrometers, EFMS, a classical mass spectrometer with a magnet, and a time of flight instrument. This is a very precise mass spectrometer where we can resolve individual peaks on 1 integer mass. You see N and CH2, and the CH with the heavy carbon isotopes here, well resolved. This here, the time of flight was measuring much quicker, but with less resolution, of course. We had a pressure sensor, which measured the total density and also the ram pressure, giving you the wind, so the wind speed. And finally, the computer was built in '96. At that time, we already had computers, but not Pentium or whatever. It was a 386, but it still works and works and works. So that's Rosina. It was launched after about 8 years of development. And that's when Hans Balsiger retired. He retired in 2003. So the next 10 years were my 10 years. I had an easy time. I just had the cruise phase, flying through space. And that's where I learned patience. 10 years is a long time, but I can tell you it was not boring at all. We have plenty to do to prepare for the real mission at the Comet. So the launch should have been in 2003. There was an Ariane failure in late 2002. We were not allowed to launch, so we had to postpone the launch for 1 year, and we finally launched in 2004. We had to change the Comet because Comet Virtanen did not wait for us. And we had, and the final Comet was Churyumov-Gerasimenko, or just Chury. 10 years of cruise phase till in 2014. That's now exactly 10 years. It's 20 years since launch this year, 10 years since arrival at the Comet. And in March 2014, we had the first pixel on the camera, which is the Comet here, just 1 pixel. But then it went really fast. In June, we could resolve it. In July, we saw that it's a funny comet. And in August, we met with the comet. We had the same velocity, and we could orbit around the comet for the rest of the time. In November, there was the landing of the Philae lander. In February, we were very close to the comet. You see the shadow of the spacecraft here. This is a very peculiar picture here because it's not very often that you see the shadow of a spacecraft on a body. And then finally, March, July, the perihelion passage, but the comet got really active. And then we followed the comet out to almost 4 AU, and we softly crash landed on the comet end of September 2016. So that was my time. I crashed more or less together with the comet. A few months later, I retired at the age of 65. But before that, in 2014, the comet 3.8 AU, we got the first good results from our instrument. And we posted the results, and journalists were very eager to take it up. And you see here it's in English what we saw. We saw that, or we smelled that the comet really smelled badly. And that's when I realized that with such a mission, you can get to the people, not to students, but really to the people. Because this article here, the comet smells of horse stable, that's the title here. That's the Swiss Farmers newspaper. It's the only time when the Swiss Farmers newspaper had a space instrument, space mission on its first page here. So I realized that you can really engage the public by telling them what you are doing in space, that people are eager to hear. Of course, we also got scientific, maybe scientifically more important results, like the overage in cometary water, which shows that our water is not from comets. We found O2 oxygen on the comet. We found ammonium salts in the comet, and also phosphorus monoxide, all important molecules if we are looking for how life finally evolved on Earth. So after I crashed myself in 2017, my successor, Mr. Rubin, took over, and he's still doing data analysis. We got 2 million data sets, mass spectra, and the analysis is not yet finished. I have the privilege that I'm an emerita professor. I still have a working space at the university, and I'm still helping to analyze the data. I'm helping the young postdocs and PhD students who look at this data even now. But it's clear it's not about these 4 people here. The mission or the instrument is about teamwork. Without the team, without a good team where everybody trusts the other, such an endeavor is definitely not possible. So I realized that with space research and astrophysics, you can engage the public much better than with solid state physics, actually, or with physical chemistry, which is much more difficult to tell to people what it's about. Even if it's as a physicist, it's also extremely fascinating. So what did we do to engage young people in STEM, in science, technology, mathematics and engineering here? My experience is that you have to start early, because you lose the young ones if you don't tell them at an early stage that STEM is interesting. And this has also to do with cultural obstacles. As I showed you the Google pages, that's a cultural obstacle. Girls see that they should play with play houses with dolls, or they should be beautiful, and boys see a different picture, and that's a cultural obstacle. So I really start early. These are my granddaughters. Here, 10 months old. She's a little bit less than 3 years old, and I explain them the space shuttle. And you see, even at this age, she is definitely fascinated by the space shuttle. But we did a lot of things starting from kindergarten. At one time, we had 175 years of the University of Bern, so we did a lot of things for the public. And what we did is, for example, we had rocket building competitions, and we started in kindergarten. So kindergarten could build a rocket that didn't have to fly. They could build it as they liked. All these rockets are larger than the kids which built them, but they are beautiful. They are just beautiful, with a lot of details, with a lot of engagement, passion, and also patience of the kids who were building them. That was a huge success. We then had a rocket building competition for these are plastic bottle rockets, which you probably know. They always a very huge success for all kinds of children, all ages, I would say. So they had to build the rockets. They could decorate them as they liked. We built the launch station, which had a counter and also some fog. And you see how people were fascinated. We did that during a fair in Bern, and we had a lot of public watching it, and you see all kids. Here, this boy, this girl, this, I guess it's a girl, were really fascinated by these small rockets. And then we finally did the rocket building competition for the older kids, grades 5 to 9. These have small rocket motors, these rockets here. And in order to do it safely and to help the teachers to do that in school, we sent our people, bachelor students, master students, people from the mechanical department. We sent them into school to give a lecture on how to build rockets and what the principle of rockets is. So some physics and some engineering. And then during one day at this fair, we launched all these rockets, and finally we got the winner. The winner was the one who flew highest during this day. We measured it. We do very regularly, we do school visits, and we even go very far from Bern. You see, that's somewhere in the country. It's a school class. They built an Ariane here, a very nice big Ariane. And we tell them about space research. We tell them about the physics behind rockets. We do experiments with them. We build comets, as you see here. And this is always met by a lot of enthusiasm by the kids. So we never have problem with discipline or whatever. They just love when we come. In Switzerland, you have one day in November where kids are supposed, kids for 11 to 12 years old, they are supposed to go with their either father or mother to the working place of their parent to see what their parents actually work. But of course, there are some workplaces where it's not very feasible to take your child along for a whole day. So we offer places for kids in our institute. Here you see them visiting the shaker. Again, they learn about vibration, they learn about resonances at an early age, and it doesn't matter if they are male or female, they just are passionate about what they see. Here they learn soldering. They do a small gadget together with our apprentices in mechanics. They teach them. They love to teach them. That's always good. And here they learn about the solar system in our institute. Then we also have even weeks for high school students in the institute where they can look what happens in the labs, where they can do their own experiments. And so this is for advanced high school students shortly before they have to decide what they want to do at university. Another thing which we do for a few years now, there is a fair in Basel, Fantasy Basel. It's about comics. So people come in all kind of costumes, as you see here. And of course, aliens is always a big thing if you talk about comics. So we take this chance and show them the physical facts behind aliens here. So we go there and do some science in a fun way, of course, but to show them that aliens is probably not very realistic, but that there are a lot of good things and interesting things out there in space. As I said, it's a so you not only have to convince children, you also have to convince the parents and the grandparents that STEM is interesting, that STEM is also for girls and not only for boys. So we do Nights of the Stars, making planets, exoplanets with the younger ones, even constructing a small telescope with the larger ones, the older ones, or making a star chart here and then observing at night if night is good. So that's for whole families, and they come. And I think we can convince families that this is something their children might be interested in and might need some support from the parents and grandparents to finally end up in a STEM study. And I give a lot of public outreach talks still at my age. Last year it was 49, so almost one a week. And it's all kinds of public, from the younger to the older. So sometimes there are kids in my talks. Sometimes there are older people or anything in between. And here, that's the Swiss government. We don't have one president. We have actually 7. And these 7, which is good because the power is very much distributed between the 7, which is very good. And you see here, these are the Swiss government, which looks at the Rosina instrument. Even the government, you can interest for what you are doing. And that's, of course, important because they give you the money to build such things. So finally, what's the result? Does it help if we engage? Because it needs a lot of resources, people who are willing to do these outreach activities, and they do it mostly in their spare times, not during not during work time. They do it not for money, they just do it for patience. And it needs a lot of patience to achieve something. So, but what we can say, the students in STEM at the University of Bern is indeed increasing. Not a lot, it's not a factor, but it's 10% for male students and it's 20% for female students. And I think not all, but part of it is due to our work we are doing in outreach. And it's clear the public is keen to learn about astronomy, astrophysics. And because the public is paying our salaries by, yeah, they have to. It's very important that the public sees what we are doing with their money. But of course, as I said, it needs patience, and it also needs team play because you can not do this alone, as you cannot do space research all by yourself. Thank you very much.
Yeah, Kathrin, thank you so much for this very, I would say, very interesting, fascinating talk and how and describing your personal effort. I think is I could hardly imagine you have to give a public lecture each week.
It's sometimes more than one per week because in summer it's a quiet period and over Christmas it's quiet. So it's sometimes it's 4 per week, which is a lot. Yes.
You must be a superwoman.
No.
You could go to the movie, go to Hollywood. Okay,
I
great.
love it. And it's each time it's different because it's different people. It's a different location, it's different people, it's different ages. And it's not, I don't talk about the same thing all the time.
And you go across the country, I suppose, not just in Bern,
Yes,
right?
yes, I go across. I even go to other countries, especially Germany.
I know you talk about plan A, plan B, plan C, and at the end you only have plan C. I might have told you that plan A was a proposal to ESA to have a sample return mission. The request was to ask ESA to initiate discussion with NASA as for cooperation. And it was Johannes guys who asked me to write that proposal to ESA, and so for me it was more than 40 years.
Yeah,
40
yeah.
years, yes.
Yeah, it
Okay.
was in 85 or so that it started.
Yeah. Actually, when I look back, the proposal was submitted in 1983.
Yeah, even, yeah.
So well before the Giotto encounter. So Johannes was so confident that the Giotto will be successful,
Yeah.
Okay, great. Anyone in the audience have questions? If they could either raise your hands or maybe Sophie could also check the chat box if there are any questions or comments. Kathrin's talk cover several parts. One part was, of course, all having to do with the growth of a scientist. And the first part, as I can see, is that she emphasized the importance of having mentors, right? And mentoring is very important in higher education, in cultivating research talents, and obviously Professor Johannes guys and also Professor Hans Bausiger, they were very good, excellent mentors. I think Kathrin, you in a way you're fortunate to have them as your mentors, right?
Yes, of course. Yeah, it started even earlier. I had a very good PhD mentor, which was a woman, and that showed me that women can do it, because it's the experience I had before that. It was not well. My mother wasn't a medical doctor, so she was already very well educated, but otherwise it was really my PhD mentor, a woman who showed me that women can do it.
And obviously you're also doing a lot of mentoring now these days to help the young scientists.
Yes, I think I have to give back what I got.
Right. And then second part, of course, is that when you have become a mature and experienced scientist, you realize and tell us that for that you need to have passion and patience and also team play. Yeah, 3P's. And then to these days, you're dedicating a lot of your time and energy to science education to bring the young people, to STEM. I think that's a very, very nice development as a scientist, yeah, and perhaps it's for many of us to follow also. Okay, any question from the audience? Of course, there's parts having to do with cometary physics. That is you could also ask that question too, if you're interested in that.
Of course, yeah.
And I'm impressed by that how you have introduced the rocket science to kindergartens. Yeah.
Yeah. That was really, we did that for all ages. So kindergarten, they didn't have to fly, but they were actually the nicest rockets. They were beautiful, and we had an exhibition of them. Many people saw them, and everybody was
I think that we are
happy
going to.
with. Yeah. And there was, of course,
right.
there were prizes for the kindergartens and for the others. So the oldest category, they could even go to ESTEC, the winner of the oldest category.
So do I see any questions? There's a Judy yeah, can you speak up?
Hi. I'm not a science teacher, I'm an English teacher. And my question is, sometimes when I discuss with my female students, they're really good at science already, but they somehow still think that they're just not as good. So how do you think as an English teacher, I can provide them evidence or how to convince them that they're just as good? Thank you.
You know, the experience here is that sometimes it's good to separate. We have mixed classes, men and women, or girls and boys together on all levels, but sometimes it's better to separate them because otherwise boys will always be louder. And so if you separate them, and as an English teacher, of course, you can let them then talk about science, about engineering, but separate them from the boys when you do that. Because otherwise it's just the boys. And girls are much more quiet. It's very obvious if it goes for computers. If you give them a task to be done on a computer, what will happen? The boys will start immediately to hammer on the computer. And girls will first think and then do the right thing. But they are then late. So that's when it's better to really separate female and male students. And then they can discuss in English, I guess, on why girls think they cannot do it as well as boys. Maybe that helps. Just to become aware of the culture. These are cultural obstacles. It's what I showed you, the Google page. It's very symptomatic. So I don't know Taiwan, but here in Switzerland, we are a very technological country. We think that men and women are equal and so on. It's not true. It's the cultural obstacle which is still there.
Right. I mean so I really admire women scientists because they have to do extra hard, try extra hard than the male scientists, right? To achieve the same to make the same achievement, if not more.
Yeah. Yeah.
But I should tell you my experience when I was in high school. In my class, the top science students were always female. Okay.
Yes. When I was in high school, my math teacher told me once, the best students are always female, and the worst are always female. These are girls who gave up, you know.
Yeah. But the problem is that the best students, the best female students, they might still consider them that they are not good for science, and the worst male students, they will still think that they're good for science.
Yeah. Girls normally tell you if they are successful that they were just lucky. And boys tell you that they are successful because they are good.
Such a terrible person.
That's the difference. And we work on it, but I don't know. I have two girls. They still experienced similar things in school as I did 35 years before. Now I have two granddaughters. I don't have a grandson. I have two granddaughters. I will see how they will fare in school.
Yes.
At least at the moment, they like to play with the space shuttle.
So do we have other questions, or the teachers from the girl highs? We have a number of very famous girl high schools in Taiwan, and some of the graduates are great scientists too.
Yeah, I think that's not so bad to have girls-only schools for STEM. They are more confident that in the end that they can do it than if you are in a mixed class.
So any other questions? I mean, I think that it's not useful that we have a scientist from Switzerland to tell us, her. I won't say that it's her life story, but I mean, her long.
That's my experience, and I think if I can tell that to people, it might help to look at things a little bit differently and to see where the problems are.
What we might do is that because Kathrin, I mean, Sophia might have told you that we would record this video, right?
Yes.
And we will see whether we could somehow add subtitle to your lectures, so that some people who are not so good in English can also understand what you try to tell people, right? I mean, those are very, very important message in there, because the thing you're talking about, we encounter that very often also in Taiwan, and it's good to see how you, as a female scientist, would stand up and help, and in fact you saw the results. I mean, just by single-handedly, you increase the male STEM enrollment by 10%.
Yeah, it's not single-handedly. You know, there is a team. I'm a team player.
Women by 20%. I mean, that's a good. You should get a fair price.
Yeah.
Okay, great. If there are no other questions, which I don't see now, and then we would end this lecture today. And I want to thank Kathrin once again so very much, and hope to have to meet you again next time, someplace, sometime, and healthy, and then successful.
Same to you.
I'm happy. Yeah.
Yeah,
thank you.
I am happy, you know.
Right, good. I'm
can
happy
see that.
in
what I'm doing. I'm happy with my family, with my granddaughters. So yes, and with
how many grandchildren you have, by the way?
Grandchildren, two.
Two.
One
Okay.
3 years
all
old.
Girls?
So
all girls.
Girls, both girls. Yes.
And I'm sure you train them to become a military physicist.
Yeah, we start with the space shuttle. That's the first step.
Okay, great.
Okay.
It's fantastic to a grandmother like that. Okay, bye-bye.
Okay, have a good evening.
Yeah, bye-bye.
Bye-bye.